Hi everyone, we're just going to go really quickly over the Chapter 9 Transformations Test Review worksheet. If you need some explanations, I hope that you can kind of listen to my voice and hear the explanations of what you need. But feel free to send me emails if you're still feeling stuck on anything. And if you feel like you don't need explanations, feel free to kind of skip past my voiceover. And just look for the answers and make sure that what you have is lining up with what I have. If it doesn't line up with what I have, then go back and listen to my voiceover and see if my explanation makes sense or if you have a question or anything like that. So here we go. 1 through 4 were these off the grid rotations with the weird regular shapes. So since this is an octagon and it tells us it's regular, that means that all of the 8 sides are congruent to each other, which means that all of these triangles are broken down basically into congruent triangles, right? Because we have, here's the center. Each of these sides is going to be congruent. So those would be like isosceles triangles that are all congruent to each other. That means that all of these central angles are going to be the same angle. So there's 8 of the same angles. We know that a circle forms 360 degrees. So if I do 360 and divide it into 8 parts, that gets me 45, right? So that tells me that each of my angles in here has 45 degrees, which I've actually kind of noted up in this angle up here. So if it asks me to do a 45-degree rotation of G about the point Z, that basically means remember we're always going to the left counterclockwise unless we have negative degrees, which we won't. So always go to the left. So if I start with G and just do one 45-degree jump, that ends me up over here at I. Let's see, for rotating U 225 degrees, 225, I believe, is 5 groups of 45, right? 5 times 45 makes 225. So I'll go 1, 2, 3, 4, 5 groups of 25, and that ends me up at I actually again. A few people in the feedback gave me some feedback that they needed help with taking the segments and rotating them. Basically, what I would recommend doing is kind of take each point individually. So take G and say, or sorry, I mean take EI and say, okay, I'm going to rotate point E 270 degrees. Well, 270 is 6 groups of 45, right? 45 times 6 makes 270. So rotate E 6 groups around, 1, 2, 3, 4, 5, 6. So E is going to map to G. When I take I and move it 1, 2, 3, 4, 5, 6 places around, it should end up at H. So E goes to G and I goes to H. That means that that whole segment is actually just going to go from here 6 places around to this GH segment right here. So same thing with segment ST. We're going from right here. 135 is kind of 3 hops around the octagon. So we're going 1, 2, 3, and it ends up at this new segment right here, which is IG. 5 through 7, I went ahead and just copied these out of my answer key that I had handwritten because these little guys down here take forever to type up. So number 5 is a rotation, and it's just going 90 degrees standard counterclockwise to the left, and always about the origin, right? We're not going to do anything crazy. By the way, remember we kind of had that question about some of those on the rotations homework that were not about the center on those off the grid rotations. Just like the last slide that I showed you and just like this slide, we're pretty much going to always stick with origin rotation. So those ones on the homework were kind of the challenge problem. So we're rotating 90 degrees. So we'll rate lowercase r for rotation, 90 degrees about the origin. And if you're feeling fancy, you can say that we're taking triangle ABC. And you could even say that it equals triangle A prime, B prime, C prime. On number 6, we are doing a translation, right? This looks like a rigid motion. So this shape to this shape, it's not getting bigger or smaller, and it's not flipping or turning, it's just moving, right? So from C prime, 1, 2, 3, 4, 5, 6, 7, we're going backwards 7 on the x-axis and up 2. And if you notice, actually, I just realized this as I was speaking, that we're actually going from this shape to this shape. So don't make the same mistake as me when I was talking. Notice that these ones don't have prime notation on them. So we're actually going to start here and go over here, which is why my rule says positive 7 and negative 2, because 10 minutes ago, Miss Allen was making a lot more sense. So we're going to go positive 7, negative 2. Make sure you're matching up corresponding shapes here. So translation. 7 is a reflection, and I just said that we're reflecting across the x-axis, but you could also call that line y equals 0. 8 through 11 was giving us these 3 points and asking us to just do the transformation. So we've got some reflections and some translations here. Remember that I suggest that you guys always draw the pre-image before you draw the image so that you can kind of compare the two. So I actually went ahead and drew the pre-image for every single problem here. You need to make sure that at least you have your images on 4 separate graphs, right? I've told you guys before, don't try to squish them all onto one single graph. It just gets really messy. So number 8 is going to be reflecting across x equals -1. So we take all our points, flip them over. Number 9, we're reflecting across the y-axis, which of course is our vertical axis right down the middle. So here's my triangle FGH, flip it over the y-axis, make sure you have your points labeled. On number 10, it's just a kind of a regular translation. So we're taking triangle FGH and moving it backwards 3, -3 on the x-axis, up 2 on the y-axis, and there's our new triangle. Make sure you have your points labeled with primes. And number 11, I am translating +2, -2. So going from my original triangle forwards 2 on the x direction and down 2 in the y direction. And again, make sure that you have your points labeled. If you don't have enough graph paper, if that's a problem, I have seen some people doing some really pretty and creative graphs using notebook paper. So just kind of take a straight edge or even your ID card and just draw your own little graphs on lined paper. It doesn't have to be perfect, but just so you kind of have a grid there and you don't have to draw all of these images on the same graph because that just gets really hard to look at. 12 through 14, we're doing some glide reflections, if you see here. Remember with glide reflections, we have to start with the translation first and then we reflect. In my original answer key that I did several years ago, I actually had done them all backwards and had done reflections first and then translation. So when I looked at it, I was like, whoa, that doesn't make sense. So make sure that you have first translated +3 and over 1, and then we reflect across this line x equals 4 here. And I've seen some people doing these really pretty dotted lines for your kind of in-between translation steps. So I thought I would kind of steal that technique. So there's my in-between step. And here's my final image over here labeled with J prime, K prime, and L prime. On number 13, my line was y equals 2, but of course I first have to do my translation. So I'm going from here, +3 and +3. Sorry, +3 on x, +3 on y. Ends up in the same place coincidentally. And then I'm going to just reflect over that y equals 2 for each one of my points. And then for number 14, we're starting by translating up 5 on the y-axis. So I just went up 5, draw in that line x equals 2, and then reflect everything over that line. So here's my final image over here. And number 15, we're dilating by a scale factor of 3. So you see here, I actually took all of my points and wrote out my new points. This is something that helps me every single time I do a dilation is to just write out my new points. Otherwise, I tend to get pretty lost. So if A was -2, 0, we're just taking everything and multiplying by 3, right? So A goes from -2, 0 to -6, 0. B goes from 0, 4 to 0, 12, and that one actually ended up off of my paper because I didn't plan ahead quite right. So just know that it should kind of be right up here. C goes to 6, 6 for C prime, and then D goes to 0, -6 for D prime down here. 16 was convenient because it was a reduction. It actually got quite a bit smaller because the scale factor is a half. So I just took all of my original points and just cut them in half and then regraphed my shape down here. And then for 17 and 18, we're doing rotation. So I'm starting here. I'm rotating around 90 degrees counterclockwise. So I should end up down here. And remember, I basically can just take my paper and kind of turn it to the side, regraph my shape here, and then turn my paper back kind of to a normal orientation. So this is where it would end up for a 90-degree rotation. And then 180 degrees should end up down in this corner over here. And that's all for today. So again, if you have any questions, please let me know and make sure you get this assignment turned into teams before the weekend is over. Thanks.